Topic 1, Introduction to Matter. Lesson 1, Describing and Classifying Matter. And that'll be on pages 4 to 13 in our new textbook. All right, so we have our connect it, which is figure 1. So, several substances are shown in figure 1, sorry. 2 of the substances are in 2 different forms. Label these substances and each of their forms on the image. So first we'll have hot liquid lava and cool hardened rock. And secondly, we have liquid water and water vapor. Now, is there any matter in figure 1 that you cannot see? And the answer would be yes. Air, substances dissolved in water like salt, etc. Then what substance might impact the formation of volcanic rock? The water cools the lava so that it forms the rock. All right, so matter. Matter is anything that has mass and takes up space. So wood, metal, paper, glass, cloth, plastic, and air are all matter. One of the first steps in classifying matter is to determine whether something is a substance. So a substance is a single kind of matter that always has a specific makeup or composition. Chemistry is the study of matter and how it changes. So here we have examples of solid, liquid, and gas, and obviously examples of all of those. Some are a little funky. Alright, so now we're going to discuss physical properties versus chemical properties. And a physical property is a characteristic that can be observed without changing the matter into another type of matter. An example is that water boils at 212 degrees Fahrenheit and freezes at 32 degrees Fahrenheit. You can do both of these things, but it doesn't change the fact that the chemical composition is still water, or H2O. So what are some other examples of a physical property? And when we're thinking about these, we need to think about our senses. So some physical properties of matter could include color, hardness, malleability, solubility, electrical conductivity, density, melting point, and boiling point. Then, in comparison, chemical properties are characteristics that describe something's ability to become something else. So an example is food rotting. Other examples of chemical properties are rusting, flammability, burning, corrosion, and reactivity. Physical and chemical properties. So before we begin this, let's do the reading check. So flammability is a measure of how easily something burns. Is this a physical or chemical property? Explain using an example. So if we remember from the previous slide, it's a chemical property. When substances burn, they are reacting with oxygen to become something else. For example, methane is flammable because when it combines with oxygen, it burns. So now we're going to do the physical and chemical properties. Can you tell physical and chemical properties apart? We're going to analyze the photos and read their captions. We'll write physical or chemical next to the property. Then we will write below each photo evidence that guided us to classify the properties as physical or chemical. So first we have oxygen is a substance that dissolves in water. Fish absorb oxygen from the water. When dissolved oxygen levels are low, it can be hard for organisms to survive. Now, do we think that's a physical or chemical property? And it's going to be a physical because the oxygen dissolves in the water, but it is still oxygen. It doesn't change. Now, water and carbon dioxide in the leaves of the coconut palm tree are converted to oxygen and sugar, thanks to the energy provided by the sun. Is this going to be a chemical or a physical property? And it's a chemical. The evidence being that the substances are converted to two other substances. All right, if iron is exposed to air and water, it can rust. Is that physical or chemical? going to be chemical. The iron becomes a new substance after reacting with air and water. Finally, wood tends to be hard and relatively inflexible, especially when it's been dried. This is why wood is an excellent building material. So this is going to be a physical property. Hardness and inflexibility are physical properties. Wood is not being changed to something else, it's just being cut up. All right, components of matter. So there are a lot of tiny particles we can see, such as grains of sand. Tiny grains of sand, however, have even smaller particles inside of them. Does anyone remember what those tiny particles are called? So here in our image here to the right, we have matter, which is broken down into pure substances or mixtures. With a pure substance, you have elements and compounds. With mixtures, you have homogeneous mixtures and heterogeneous mixtures. Again, there goes our root words of homo and hetero. Homo meaning the same, hetero meaning different or apart. All right, and on that last page of notes, if you thought it was atoms, you were right. So an atom is the basic unit from which all matter is made. There are different types of atoms, but all atoms have the same basic structure. An atom has a positively charged center, which is the nucleus, and it contains smaller particles. And then there's the negatively charged particles that circle around the nucleus to form a cloud of this negative charge. So here in this image, we can see the nucleus, which is made up of protons and neutrons, and then the outer part, which is the negatively charged particles, are our electrons. Elements. Elements are substances that are made up of only one type of atom. So here to the right, we're going to see our periodic table of elements. And you can look at the periodic table of elements on page 102 to 103 in your textbook. So elements are represented with one or two symbols. The first letter is always a capital letter, and the second is always a lowercase letter. All elements are different in their own way, but they may have common features with other elements. And they are sorted that way in the periodic table. Molecules. A molecule is a group of two or more atoms held together by chemical bonds. Atoms can combine with other atoms to form a chemical bond. So the four molecules shown here are made of different combinations of carbon, oxygen, or hydrogen atoms. Below each molecule will list the types of atoms in it and how many atoms there are of each type. The first answer is completed in an example. So we have water, which has one oxygen atom and two hydrogen atoms. So because there's one oxygen atom, we know that the red is the oxygen and the white is the hydrogen. So for the next one, we have two oxygen atoms because there are two red atoms. For the third, we have carbon dioxide, so we know we have two oxygen atoms, and then we're going to also have one carbon atom. For methane, we have our one carbon atom, and then we have four hydrogen atoms. Next, we need to draw a model of a two-atom molecule of hydrogen and label the atoms. So here you should have an image very similar to this oxygen image and this image here, and labeled each atom as hydrogen. So one on the left, one on the right. To cover again, chemical bond is a force of attraction between two or more atoms. So that would be all of these. So water, oxygen combining with itself, carbon dioxide, methane, hydrogen combining with itself, all of those are chemical bonds. Compounds. A A compound is a substance made of two or more elements that are chemically combined in a set ratio. So compounds are written by a chemical formula. Examples would be H2O, CO2, C6H12O6. When elements combine, they form compounds with properties different from those of the individual elements. So we're going to look at figure 5 for an example. So here we have C2H6O, and that is ethanol. So compound from corn, figure 5. Ethanol is a chemical compound made from sugars in corn and other plants. It can be burned to power engines. So we use ethanol as fuel to power lots of different things, and of course we know that it burns. We are going to go ahead and do the reading check before we move on to our next topic. So, how are pure carbon, oxygen, and hydrogen different from the compound ethanol, which contains all three of these elements? So, ethanol is a compound, while pure carbon, oxygen, and hydrogen are molecules each made of a single element. Ethanol also has different properties from the pure elements. It is made from sugars in corn. Types of mixtures. So a mixture is made up of two or more substances that are together in the same place, but their atoms are not chemically bonded. So mixtures differ from compounds in that a mixture keeps its own properties. So a homogeneous mixture is difficult or impossible to see the different parts. A heterogeneous mixture can easily be separated. So in this image we have A and B. Which one can easily be separated? Obviously that's going to be A with the nuts, so it would be a heterogeneous mixture. Whereas B would be wow, words are hard, a homogeneous mixture because it's difficult or impossible to see the different parts. So continuing types of mixtures. If you want to separate a mixture, you need to divide its parts according to their properties. This is possible because the substances in a mixture retain their own properties. So the methods you can use to separate the parts of a mixture include distillation, evaporation, filtration, and magnetic attraction. Distillation involves separating liquids by boiling them. Evaporation is a good way to separate dissolved or suspended substances from water. So this is how sea salt is harvested from the ocean. Filtration is when you filter something through. So this is a lot of the times used with water, or a good example is water. When we're filtering out some of the chemicals or particles that are in the water, we can use filters to filter that out, keep the big stuff out, and just have the fine parts left in. And then magnetic attraction is when you use a magnet to pull anything that's magnetic out of the mixture. So pretty simple stuff there. Now we're going to go ahead and do the reading check. Think about a lake. Would you describe it as homogeneous mixture, a heterogeneous mixture, or both? And explain. So the best answer is going to be that it's both. The water itself is a solution, but the water has lots of other stuff in it, including algae, fish, and other organisms. And those organisms are going to make it that heterogeneous mixture. All right, so here we have some interesting options or varieties of mixtures versus compounds. Which one's which? So we have a cake, we have cake mix, we have Italian dressing, water in a bottle. We have our little diagram with the different things in it with densities and all of that fun stuff that keep them separated. We have seawater and then we have salt. So which is going to be a mixture and which is going to be a compound? If we have cake, is that going to be a mixture or a compound? And it's going to be a compound because it's become something else. So if it was a mixture, there would be ways to take the parts back and get them back to their original form, right? Because they have those properties. If we have a cake, we can't add water to the cake to get the cake mix back. There's not anything we can do to get it back to its original form. It's something completely new that can't be changed. Of course, unless you eat it, and then it kind of changes. But that's not the point here. However, cake mix, that would be a mixture because there are different ingredients in it that could be separated. Italian dressing would be a mixture. You could separate things. Water is going to be a compound, unless of course there are things in it. So because it's pure water, we're going to say that it's a compound. This bottom image is of course a mixture, a heterogeneous mixture because everything is separated already. Salt water is a mixture, and salt is sodium chloride, which is a compound. And here we have a good representation of elements, compounds, and mixtures. So we have hydrogen as the element, and it just shows the one atom. The second bottle is a compound of water, and it shows the 2 hydrogen, 1 oxygen bonds that make H2O or water. A mixture is hydrogen and oxygen, so we can see that they're together in the bottle, but they're not bonded. And then we have another example of a mixture with hydrogen and oxygen. More hydrogen this time than oxygen, and still they're separated, not combined together to form a compound, which is why they're a mixture. All right, with that, it ends our lesson 1. So now it's time to do our lesson check. So which term or terms can be used to describe this model? Element, compound, or molecule, and explain. So ammonia is a compound and a molecule because it has 2 different types of atoms. For the same reason, it is not an element. 2. What is the chemical formula for the molecule shown? That would be NH3 or H3N because there are 3 hydrogen atoms and 1 nitrogen atom. So remember that we use the subscript below for each element that's in it when we are writing the chemical formula. All right, suppose you find a website that describes the rusting of a nail as a change to only the physical properties of iron. Would that be accurate? Explain. No. Rust forms when a chemical change takes place between iron and oxygen, so it is also a change to chemical properties. Think about different mixtures that there are in the kitchen. Name and describe 2 homogeneous mixtures and 2 heterogeneous mixtures. So some examples of homogeneous. We have honey, it's uniform, golden, translucent, and soup broth, which is cloudy, yellow-brown. Heterogeneous, we have chunky salsa. There are different pieces of vegetables in a red solution. And chocolate chip ice cream. There are pieces of chocolate mixed with an opaque cream. There are lots of different things that you could also use. You guys can think about that, and if you think of something different, come show me and we'll discuss it. What is the difference between a molecule and a compound? So a molecule is a group of 2 or more atoms held together by chemical bonds, but not necessarily different types of atoms. A compound is a group of atoms of different elements. So a molecule could be hydrogen or oxygen, which are 2 examples of elements that are frequently found together, meaning that they have 2 hydrogens together and 2 oxygens together. It's a lot more rare that you would just find an oxygen in regards to the element. So that would be a molecule. But a compound has to be 2 different elements within. So